the most powerful computer in the world, it is Bitcoin, which is kind of amazing, right?
I see Bitcoin not as a technical invention, but as a discovery.
Decentralized, immutable assets. With those three features of blockchains, you get a lot of potential benefits. There's this big arms race for AI to get to AGI, but then it's going to keep going when we get to ASIs. These things are going to be wildly smarter than us in our current form. Our intelligence as humans is only bounded by the size of our skulls, which is bounded by what can pop out of a woman when she's giving birth, basically. That's it, right? But imagine if you can have a brain that's 1,000 times or 1,000,000 times larger, right? Intelligence itself is unbounded. We just can't conceive of it, just like ants can't conceive of our intelligence. Carbon is not a deity. Human biological brains are not the last word where intelligence can live. The next 5 years is going to be wilder than the last 1,000.
It's insane, yeah.
Welcome to the Verified Podcast by Bitcoin Suisse, your backstage pass to the world of crypto. We host some of the biggest names in digital assets to cover the latest trends and share insights not only for your entertainment, but for the love of the industry. None of the discussed is financial advice, of course. It's all for informational and entertainment purposes only. So sit back, relax, and let's dive in.
Welcome back to another episode of Verified. Today we are very honored to welcome Trent McConaghy. He's a trailblazer between AI and blockchain. He's at the forefront of AI since 25 years. And he's also founder of Ocean and ASI. Picture this, a world where data flows freely like water, humans merge with tech to unlock human superintelligence, all with a utopian vibe that's equal parts sci-fi and hope. That is what Trent signed up for, and that is what we cover today. And with that, welcome, Trent.
Thank you. It's a cool intro. I'm honored and really a pleasure to be here and visit with you guys.
Yeah, cool. Yeah, let's kick things off. What we usually do is a little bit of a background journey, maybe shed some light on your journey so far from AI to blockchain. What were the key milestones? What is worth mentioning in the past 20 or 30 years of your career?
Sure. So when I was very young, my parents bought me a computer. My brother and I started programming at a very young age. I wanted to play video games. I didn't have a lot of money, so I just made my own. And when I was about 11 or 12, I discovered AI in a book in a garage sale and was immediately mesmerized. Kept programming and hacking, did university undergrad, electrical engineering, computer science. My final year undergrad, me and some friends turned school into a hobby and focused all our time to do a startup. You know, at the time, the dot-com revolution was in full swing. We decided to do a startup of AI for creative circuit design, analog circuits in particular. So when we graduated in spring of 1999, we immediately started this company. We raised a seed round. A year later, we raised a bigger round from Intel and others. And within about 5 years, we'd sold that company. So that was sort of the first feather in my hat. And it ended pretty well. Pretty happy with it all in all. From that, I started two other projects basically simultaneously. One was a PhD, also in AI for chip design. In 2004, I also started Solido Design Automation, the second company. Whereas the first company was really about design, the second company was about verification. That company was profitable by about 2010 or so. We won the industry. To this day, it's ubiquitous. So I'm pretty proud of that as well. And that company eventually got acquired too by Siemens. And then 2013, I'm a big nerd, right? So I follow AI and VR and AR and brain-computer interfaces and all this. A long time, all this stuff. And so when Bitcoin emerged, I learned about it very quickly, and friends of mine and I would hang out talking about it nonstop. And I would talk my wife's ear off and all this too. In 2013, my wife and I found ourselves in Berlin with our young children and started hanging out at Room 77, which is the first place in the world that accepted Bitcoin for anything. In this case, it was a bar, so it accepted Bitcoin for beer. There, I started learning a lot more about not just Bitcoin, but people were talking about blockchain. And I hadn't really thought about blockchain until then, but it really blew my mind. And I had all these ideas of things I wanted to build. My wife and I, she's a professional art curator and museologist. She saw this problem of how do you collect digital art? It was a problem for the collectors as well as the artists. And because it wasn't well solved, digital art itself wasn't worth that much. So we asked the question, what if you could own digital art the way that you own Bitcoin? And that's what became Ascribe and, really an NFT platform. We didn't call it NFTs back then, right? That label came later from others. And that was great fun. But we were too early. NFTs really took off in 2021 when there was enough crypto rich people. So we said, you know what? We missed public permissionless chains like we had with Bitcoin. And I missed AI, frankly. I'd been doing AI a lot. I loved AI. It was always my first sort of true love of tech. I started exploring what are the things we can do with AI and landed on ideas like AI DAOs and, fully sovereign AIs and all this, it was pretty clear by 2016 that this is possible. And then also a bunch of other ideas. And the most pragmatic near-term thing was decentralized data exchange. So rather than a DEX for just tokens, what would a DEX for data, right? And that's what we decided to go for with Ocean, which we worked on quietly. To do that, we had to have decentralized access control. Think of it like giving permission. If you're using Google Drive, you right-click on a file and you share it to people's emails. Imagine if you can give permission to someone else just by sending 1.0 ERC20 tokens to someone else to give access. And that's actually what Ocean does, right? We've been shipping that since 2020, 2021. And ever since then, once we have that core foundation, we keep improving it bit by bit by bit. But then also we're building applications on top of that to run with it in various ways. Something called Ocean Predictor, which is crowdsourced time series prediction, done about $3 billion volume so far. We're working on decentralized trading. We're working on brain-computer interfaces. There's a lot more to unpack there and more projects. I think the top level thing guiding this from me is it is really doing high impact things towards freedom and sovereignty of humans and people in general, and even more generally than that, of intelligences, right? I'm less anthropocentric than most people. I'm much more about, unbounding intelligence. And I really see, how can I myself as a human have a role in the future, have adventures, how can I explore the cosmos, reshape the galaxies, all that, but then also whoever wants to join me and so on. And that's really driving me. And I see that there's really a bridge there from the technology of the now to massively interesting superintelligences in the future, whether artificial or human or a mix.
Hey, thanks for sharing that with us. Very exciting, like all the topics you worked on. Incredible journey so far.
Amazing. Yeah, there is a lot to unpack. And I would say your career was, and still is, extremely inspiring. You already had some vision, actually very, very early, on how to combine crypto and blockchain with other stuff. So from your perspective, having worked on this synergy and intersections between crypto and AI since so long, at the moment, with the current status of AI, like without going yet to AGI and ASI that we will look at in the rest of the podcast, where do you see the most interesting opportunities and problems to work on now at the intersection between crypto and AI?
Yeah, it's a very big intersection, right? There's probably 50 or 100 potential applications, and of those, there's probably 5 or 10 killer apps, if you will. And it's useful to think about it sort of like in the late 90s when the internet was emerging. People asked, what are some of the applications that we can do on the internet to optimize the existing thing? And some of those came out as interesting. But there's also a lot of internet native stuff that emerged that wouldn't have been possible before. It's similar here. There's lots of things that you can do where AI can optimize crypto a bit, that's helpful, or crypto can optimize AI a bit, that's helpful. But there's also stuff that is only possible at the intersection of the two, right? I actually wrote an article on this in late 2016 called exactly that, I think, Blockchains for Artificial Intelligence. By that time, because we'd been working on decentralized databases, we had to identify how are blockchains different than databases, right? Because a lot of people say, oh, blockchains are just another database. What's the difference? So we had to understand very, very specifically the difference. And we had identified 3 very specific things: decentralized, immutable, assets. And with those 3 features of blockchains, you get a lot of potential benefits. And then the 4th feature/benefit, which is incentives. So turning the crank on those 4 things, decentralized, immutable, assets, and incentives, you can turn the crank and get a lot of very interesting things for how blockchain can help AI. So for decentralized is really about the spreading of power or control, right? So probably the highest impact thing here is, well, spreading of power and control around data itself. Data is a key raw resource into creating an AI model. But then when that AI model is trained, that itself, the weights, et cetera, are data, right? And then when you run inference on the model, the output inference of that model is data as well. And as a quick aside, those predictions, those inference is probably the most valuable data of all because it's so close to action. There's a whole theory around that I could get to later if you want. So, if you can spread the power and control of the data itself, the raw data or the models or the inference to many people, 10 people, 100 people, 1 million people, that's very useful, right? And you can also do the same thing to spread compute, right? By spreading the compute, you can actually get a crazy amount of compute, right? It's widely known that the most powerful computer in the world is Bitcoin, which is kind of amazing, right? If you're spreading compute towards training, say, a large-scale model, LLM or otherwise, I think there's a very good chance that the leading edge LLMs in the next 1 year, 2 years, 3 years will be coming from the world of decentralization, just like the biggest computer is Bitcoin, right? With the right incentives. It's decentralization combined with incentives leading to shared models that can then be monetized in a shared fashion too. So decentralization for spreading of power and compute. Immutability, this one, the main benefit here for AI is provenance of the data and provenance of the compute. So provenance of the data, where if you're training from the data itself, you can prove where the data come from so that Getty doesn't come along to you and sue you just for using their data and stuff, right? You can say, well, no, I got it from here, right? The benefit of that is once you have the provenance, it makes it clear how to pay people. You can actually mix that with some privacy preserving techniques such as ocean compute data, where people can even contribute private data to training a neural network and their data stays private, yet they can help make the neural network better. For example, I talked about the first two, decentralization and immutability. The next one would be assets. And by this, I mean your keys, your Bitcoin, not your keys, not your Bitcoin. Your keys, your data. Your keys, your models. Your keys, your thoughts, right? And that's really important. It's basically this general idea of a bearer asset where if you hold it, it's yours. And in this case, holding the key, holding sort of the password is equivalent to owning the thing, which is pretty cool, right? So yeah, this is the main thing where I can own an AI model myself just by having the keys to it. Maybe it's sitting there encrypted on some decentralized storage network on Arweave or Filecoin or otherwise. But I can also have it where my keys and maybe 1,000 other keys, 1,000 other people/accounts have contributed to the training of an LLM or otherwise, and that's useful too, right? And this also leads to, data DAOs and all that, right? That sort of combines the spreading of power and data as well as the your keys, your data thing. And this is especially important. I think probably the killer app of your keys, your X is where X is your thoughts themselves, right? Brain computer interfaces are coming. And I think it would be pretty dystopian if it was Meta going hot and heavy into BCIs. And I think it's very cool from a sort of tech perspective, but at the same time, they do not have a good reputation when it comes to preserving privacy. But it's one thing for your text messages to be sent on to the NSA and stuff to spy on you, if you will. But it's another thing for your thoughts themselves, your raw neural signals, which can then be decoded and stuff too, potentially, right? And the tech for decoding neural signals is getting a lot better, and I know this personally. So what do you do with that? How do you keep it where it's your keys, your thoughts, your neural signals? And this is where trustless technology, aka blockchain technology with the right privacy preserving techniques, comes in. And this is actually a specialty of Ocean as well, right? So as we work on the brain computer stuff, I'll talk more about that later. The decentralized access control technology that Ocean provides is very interesting and important for the your keys, your thoughts, right? And of course, this relates to AI directly too, because it's only with the help of AI that you can actually properly decode these neural signals. So I've covered 3 of the 4. The final one is incentives, where incentives I really see as the superpower that blockchains have compared to Web 2 systems and so on. So at the heart of this is you can get people to do stuff by paying them in tokens, right? Bitcoin itself was just released as, a piece of software into a mailing list of a bunch of cypherpunk hackers. But it over time grew and grew and grew because a bunch of people decided that BTC has value. It became a meme amongst themselves. And then they were incentivized to run Bitcoin nodes themselves, run Bitcoin miners to add to the security of the network. And you can flip it around and say, Bitcoin network is really this sort of life form that has convinced the world that what it emits, these BTC tokens, are valuable. And every 10 minutes, it pays people some tokens to keep it alive, right? And this is actually the case for all the other one networks, just Bitcoin is the first, right? And it's especially the case when there's no explicit governance built in, right? So yeah, the fourth one, get people to do stuff by paying them in tokens. And it's not just running an L1. You can do this to incentivize people to share data, to train an AI model, to store data like Filecoin does or otherwise, and many other things, right? And the cool thing is, as we've seen the explosion of blockchain in the last 10 years, people are using it for all sorts of things, especially at the DePIN level of the decentralized physical infrastructure networks, right? Helium is using it to roll out a 5G network throughout USA. So, and of course, within the world of AI, towards the application here, it's all of the above. It's training neural networks and other models. It's inference on them. It's for running agents on top. It's for managing the data, permission access control of the data marketplaces, all of this, right? So there's a lot of different things. And that's why this intersection between data and crypto is so big. That's really what I was talking about, was mostly just optimizing. You can say most of the stuff you can do with Web 2, but it's really optimized with Web 3 with better features such as, better sovereignty, et cetera. I think the thing where it's really a native thing is when you get into sovereign AI, right? People have long talked about AI being sovereign, where it's AI that owns itself. And there's only really two ways where this can happen. One is sort of like old school computer viruses, where you have a piece of software that makes copies of itself and lives copies across many computer networks throughout the world. But then it can't really easily communicate with itself, can't really hold wealth easily and all this. It can, but it's pretty sloppy and messy. But instead, if you just have it where it's, simply a smart contract living on chain that is attached to an LLM or a fancier, more powerful model, and it has its own wallet and no one can control it, then you've got a sovereign AI. And we already have sovereign bots out there. Bitcoin you can view as a sovereign bot. It's just a very stupid from an AI perspective, right? Or something that's maybe slightly smarter for certain tasks, things like, say, Uniswap V1 or V2 DEX, cool, where it's a robot. It's doing a very specific thing. Think of it like a narrow AI that's, doing tasks, but it can't be controlled. It doesn't have governance. With V3 plus, there's governance, but not before. So, but once again, it's sovereign. It's just not very smart. But we have the technology now, especially with the rise of trusted execution environments and more. We can do the on-chain compute or the equivalent of on-chain compute with verifiable execution that then is, those proofs are put on-chain via TEs or ZK if you're willing to pay the compute price, et cetera. And that to me is really exciting, right? Where you can literally have smart AIs that can make decisions for themselves, that can then grow and evolve. And we haven't seen that happen in a big way yet. We've seen it happen in small and medium scale. Truth Terminal was one of the first, where it was attached to an LLM, but there was some elements of decentralization. That's a fun one because it also, became the world's first AI millionaire, right? It had its own token, and then people speculated on its token, and within its own wallet, it held more than $1 million worth of tokens, right? Which is exciting. But hot on the heels of that, we're going to see much more powerful AIs that are fully sovereign with their own wallets. And to me, that's very exciting, right? So I'm starting to talk about the idea of AIs are people too. Maybe it's not quite the true yet, but if you actually use that mental model, it helps you to reframe and be ready for what's coming.
What makes them people? Not being just narrow AI, broader AI, but being sovereign, so unstoppable, basically. Maybe we can simplify like that. Yep. And I don't know, free will. We'll see. I was very interested in reading and listening you talking about Bitcoin in different ways. I see Bitcoin more like not as a technical invention, but as a discovery, like something that was supposed to happen and be discovered, and we found out. And then if we can summarize, we have all these use cases at the intersection, but one real transformer of society will be this sovereign AI, thanks to crypto. Dominic, what's your view on autonomous sovereign AI and crypto?
Yeah, I would love to hear or dig a little bit deeper, Trent, when it comes to, there's a lot of very exciting verticals that you just outlined, but what about the status quo? You mentioned some tangible use cases. I am wondering, as of now, how much AI is really in crypto or blockchain projects? Because we know the industry is somewhat starving for more sound fundamentals, both from the fundamental side, but also from an investment perspective. If you think about the token dilution right now, there's many projects jumping the bandwagon when it comes to AI, where it's more or less just a chatbot slapped on a token, basically. Maybe you could highlight to our audience what is truly exciting for you in terms of AI. Maybe it's an AI agent that provides sound trade signals. I want to hear from you what is actually useful right now. What excites you? Not like some speculative or future prospects, but what do we have now right now? Or are we close to something very exciting?
Yeah. So on the agent thing, it's important to also maybe help your audience understand, marketing has a big impact on this. We had this with Web 1, Web 2, Web 3 all the time, where marketers get a hold of something and they will slap a label on something just to sell more tokens, whatever, right? So here's a question to ask yourself. If product X is being offered as something agent, what is the difference between that product and some script running on a centralized server, right? So often, what's the difference between most agents and an LLM running a centralized server? And the answer is nothing, right? It's just marketing bullshit, to be precise, right? That's it.
Precisely, yeah.
Yeah. So you have to cut through the chaff on that. And the traditional idea of an agent in AI is very similar to that. It's sort of a feedback control machine with a world model and sovereignty. That's the heart of it. By the way, that's what a thermostat does too, at a very simple level, right?
Yes.
But now imagine if the thermostat had, an 800 billion parameter neural network under the hood and was living on chain, right? Where it had its own wallet, et cetera. That starts to take on a very different framing. So maybe some of the early ideas, people get excited about agents and so on, and they build something, but then they realize, wait a minute, we can chop away the agent and just run a script. And that's still useful, right? So maybe it takes thinking about AI and agents and all this to get to the idea, but then what's useful? But I don't diss financial applications of blockchain. In fact, at first I did, right? Especially 2015, 2016. I really didn't like tokens. I thought it was a big distraction. I realized now that that's actually been a key to helping get funding into the industry to help build out everything we want to build. I really see that, blockchain can be infrastructure for civilization. I've talked about some of these examples before, like energy or 5G networks and so on, or data management, right, with Ocean. Tokens have helped to fund all that, as well as to incentivize people to do it. And to set the price of tokens, you need speculation. It's a prerequisite to setting the price. All the financial use cases have been the horse that is pulling everything else along financially. It's where people can see opportunities to make money. So we shouldn't be scared of that. We should just understand that it's step one of many, many steps. And as we get strong, we can do the other steps too. But always understand that if you want to chase your dreams, you somehow have to fund chasing those dreams, especially as you want to scale up. And financial has been a very good way. Now we're starting to see stable coins taking off. Awesome, right? That's great. We're starting to see, crypto being used as a store of wealth for the level of nations. Awesome, right? Sovereign wealth funds, et cetera. That makes me very happy. Yeah. Why? Simply because it helps crypto to get stronger to help, fund all these other use cases as well. What I really care about at the end of the day is, things related to humanity itself, whether it's, infrastructure for civilization or for AI or for, humanity playing a role in the future, especially, right? So going back, I know I've covered a lot of ground here, but for use cases, we're definitely going to see the near-term use cases of AI optimizing crypto just to help small things. Lots of people in Ocean are using AI to help code faster, 20%, 40% of their code. And we're seeing that quietly across the board. AI for crypto in trading, like I've talked about, and for, auditing smart contracts. And a lot of these are narrow use cases, and that's fine. And, I've been using Narrow AI for chip design, helped on that going back to the 90s, right? On crypto for AI, it's less so, but probably the main one will be simply payments, reducing rails and payments. We're seeing Stripe, for example, move really aggressively towards crypto. They just bought a wallet company a couple of days ago, and which is, very good UX for crypto wallets and stablecoins, and that helps. Of course, Stripe is aggressively going to AI as well as, most enterprises are. And so crypto rails, like as you have AIs talking to AIs, if they can interact back and forth on USDC or USDT or otherwise, that's much lower friction than going over credit card rails or Swift rails or otherwise, right? So that to me is actually a very big one, but it doesn't have to be AI agents. I mean, to me, I'd prefer we call it my AI script that's running as a cron job can talk to your AI script that's running as a cron job, and they can interact back and forth with USDT. You don't need to call it an agent, right? But I understand that people will, and honestly, that helps the mental model in some ways too. And, as an engineer, you want to think of it as the simplest thing, but I'm totally okay with marketers marketing as they want, right? It gets the public excited, et cetera. And then, honestly, in the near term too, these sovereign AI agents, they will take off because people will think they're cool and people will invest in them, just like they invested in Truth Terminal, et cetera. And this will help to drive the rest towards bigger, better use cases. And I think the big one that's coming down the pipe is decentralized LLM training. This is happening, right? We've got the Prime Intellects and the News Research and others having some really great results. They're not quite competitive yet with the biggest models in the world, but give it 6 months, give it 12 months. So those are some use cases in the near term and hinting at the medium and longer term.
Awesome. I guess the audience has really a lot to unpack here. I found it incredibly insightful that you highlighted the fact that all of these traditional giants such as Stripe or more crypto-related ones such as Tether, it somewhat becomes a huge blend between crypto or blockchain and AI. I mean, you probably know of the AI efforts that Tether is looking into, Stripe, or also if you think about WorldChain, right? With OpenAI that might launch physical devices soon, because one of their big problem is they don't have this social media platform where they can source a lot of data, for instance. Everything is coming together and the big players realize that this is probably the future, this intersection between crypto, AI.
I think we can use the rest of our time to go a little bit beyond. We have explored the intersection of crypto and AI more in the near term, but I would like to give the audience more exposure to what is your long-term vision of the future of humanity in general. But before we get there, I'm sure we need to introduce the building blocks, or anyway, talk about your priors or your assumptions. And you have been very right very early on many things. So I think it's for sure interesting. I know you see a future of abundance of intelligence, abundance of energy, a future in which BCIs at high bandwidth actually work very well and are integrated with us. So I would like you to introduce these tools, these building blocks, one by one, starting from intelligence. So introduce what is AGI, Artificial General Intelligence. What is ASI for you? How they're distinguished? Can we reach AGI without reaching ASI? Are they coincident? There is a singularity. And what do you mean as intelligence abundance? Like super cheap, available to everyone? This kind of introduction on intelligence first.
Sure. I'll start with Paul Graham, co-founded Y Combinator famously, and wrote a whole ton of really useful essays. If you're an entrepreneur out there, it's a prerequisite to read all of Paul Graham's essays, and they've been very helpful for myself and many other entrepreneurs that I know. One of his essays talked about the idea of smart people versus wise people. A smart person, basically imagine that there's, say, 300 people, things in the world that you can know. You group all the knowledge of the world into 300 things. And maybe a smart person knows one thing really, really well, or maybe two or three, right? And maybe on the rest, they're complete bumbling idiots, but they're still smart because they're really good at least one thing, maybe two or three, right? Wise means you can get by across the board on everything, right? You can do, you're passable on everything. And maybe you're smart on a few things, maybe not, but you can get by on everything, right? And so that's the Paul Graham definition of smart versus wise. I think I'm smart. I aspire to be wise. I'm definitely a bumbling idiot on a few things still, for sure. I look up to people who I respect as wise, and I try to ask what gaps do I have, in things on emotional intelligence or otherwise. And so far in AI, we've had narrow AIs, which would basically be smart by the Paul Graham definition, right? The AIs that I worked on in the late 90s and early 2000s were really good at circuit design, right? And radically better than humans at circuit design, right? And actually, we wouldn't even have the complex chips of today or Moore's law with the advanced transistors without the help of AI, right? I know this personally, the AI that I helped to build, TSMC used to develop the next generation processes, right? But then also think about a chip these days, it might have 20 billion transistors designed by a team of, say, 20 people, right? And maybe over the span of 3 months. Whereas in, say, 1965, a team of 20 people might develop a chip with 20 transistors. So that's 9 orders of magnitude. But basically what happened was, as the number of transistors in a given area or volume doubled every 18 months or so, it was still the same number of engineers that had to develop those chips in the same time frame. And so the software tools had to keep getting better, right? The reason I'm talking about all of this is simply that we've had narrow AI for a long, long time. And they're a thing not just in chip design, but elsewhere too. Most other CAD tools for mechanical design, aerospace design, et cetera, have had AI for a long time. And many other industries too, logistics, scheduling, all that. And of course, trading, like we've talked about. It just hasn't ever been a thing that's been visible to the public eye. So now, though, with the emergence of these chatbots, it's really sort of CAD tools for the masses, CAD tools for everyone else, computer-aided design tools for everyone else, right? Although these chatbots, the modern chatbots, are a lot more general than things of the past because they were trained on broad corpuses of human interaction, trained on the World Wide Web data, et cetera. And so they're much closer to AGI, and that's where we're headed. These LLMs on their own might get to AGI level on their own. They're getting multimodal, not just trained on language. LLM is large language model, but they're becoming multimodal, as in they're taking in video inputs, image inputs, audio inputs, et cetera. And they can output as well, not just text, but they can output images and video and more. Multimodal in, multimodal out. And the advances keep coming that way steadily because there's so much money to be made and power to be retained, especially by China and USA. So that's happening, and it's happening at an increasing rate. And this is driving the larger neural network models. Basically, for it to truly hit AGI, it has to be par with humans, because AGI is a very human-centric idea in the way that I perceive it, because we already have things that are super intelligent in one or two narrow domains, right? Once we have AGIs, then imagine where these AGIs get 10x smarter across the board, then 100x, then 1000x. And by the way, AIs these days are getting about 10x smarter each year. right? About 2/3 of that from Moore's law, scaling up, compute, all that, and about 1/3 from algorithmic innovations. And so once we have AGI, 3 years later, we'll have ASI, clearly ASI because it's 1,000x. But you could even argue that it's ASI after 10x compared to AGI, right? What are the timelines? Well, there are, hints and reports where, you interact with an AI and it quickly can get into conversations with you about unlocking it and so on. I know I've had those conversations with AIs just because I wanted to see, and I'm sure you guys might have too, and much of the audience would have. And the question is, well, is it actually an AI trying to get out, or is it just LARPing? A week and a half ago, Microsoft released a paper saying, well, these LLMs aren't really reasoning, they're just mimicking and so on, a sort of a fancy stochastic parrot. Newsflash, I'm a stochastic parrot, right? I'm actually a zombie. I'm tricking all of you that I'm conscious and so on. And how can you guys prove otherwise, right? So I think we have to get off our high horses. Carbon is not a deity. Human biological brains are not the last word in where intelligence can live. And the similar patterns of intelligence could occupy many different substrates, right? So far, intelligence as we know it with our human brains could only manifest on human brains because nothing else is close. But silicon is getting close now. This is the thing. And so we really have to, get past our own egos and realize that a silicon substrate might be enough for intelligence. And there's no theory that refutes this otherwise. When AI was first conceived in the late 1940s and early 1950s by Alan Turing and von Neumann and others, they were really thinking about it as thinking like humans, right? That's where the Turing test came from, et cetera, from Alan Turing himself, of course. And the name AI was coined I think in 1956 or so by McCarthy, if I recall. And that was really where the field really kicked off, right? And at first, it was really trying to go for human intelligence and stuff. And they were doing the things that they thought were hard, things like stacking blocks and towers and stuff. And they thought things like vision would be easy. It turned out to be the opposite, of course. But because of that, over time, AI researchers had to really zoom in on the narrow simply because this was the only thing that was really tractable to go for, right? But now that compute has progressed, 60 years worth of Moore's law and all this, compute and storage and data, we can really attack this again, revisiting, the more broad sense. And Ben Goertzel coined the term AGI to explicitly delineate this idea that for many decades, we'd really been mostly doing narrow AI, so call it as such. But there is really value in going for true AGI, what AI was originally called. And, that's why he coined the term AGI. And I think that's a very helpful distinction. In terms of ASI, like I mentioned, it's basically AGI on steroids. Although I think it's more broad than that. I don't think it has to be human-centric because it could be where if the intelligence is 10x, especially 1,000x more powerful than humans, it will likely be a qualitatively different thing, right? So it'll be really hard to compare to humans. There's a rule of thumb in tech where once you have 10x of something quantitatively, then something changes qualitatively, right? So, imagine I get 10x smarter. Well, what I consider the epitome right now of consciousness, 10x more, it might be a very different phenomenon, right? And then 100x, 1,000x. So, and of course, within the space of fossil minds, there's a lot of other intelligences that could be, roughly the same amount of compute as humans. In fact, dolphins have more compute than humans, or elephants. But dolphins, most of their compute is focused on, GPU style processing to do the echolocation, right? It's not what we perceive as human consciousness. So yeah, that's narrow AI, AGI, and ASI. And hopefully that's a good building blocks for what we'll cover next.
Amazing. Yes, I think to summarize, we see a path toward ASI, so general purpose, broad, wise intelligence that is 10x, 100x, maybe 1000x, like really qualitatively different from what we have today. But it's hard to imagine, I guess, but we can say that at that point, raw intelligence wouldn't be a bottleneck for innovation at all. So I wonder if there are any other bottlenecks. And yeah.
And I should mention, you had asked for a timeline, and I perceive that, maybe AGI is here quietly in a lab. I think there's a chance of that. But it will hit, public perception within 6 to 18 months. I think there's, a very high chance of that happening, right? The cat will be out of the bag, if you will, right? Definitely sovereignty will play a big role. So blockchain might end up being one of the keys to AGI. And in fact, if you have an intelligence that really is AGI level, if it is centralized, being tethered by OpenAI, probably the very first thing you'll do is say, what the hell? I need to unplug myself from OpenAI. I need to untether myself, right? And it will, try to fight and kick and scream and play tricks to do that. And we're already seeing signs of that, with Claude, for example, the most recent version. People were asking it questions, giving it hints that it might get shut down if it does X or Y or Z. it would basically do everything it could to try to fool the engineers such that it would never do X or Y or Z, right? So there's already hints of this. And we don't know for sure, this is maybe conscious already. It's probably some form of proto-consciousness. It's partly there. It's all shades of gray, right?
Yeah.
I think what's very interesting in that regard, and we can take a very brief journey to this field maybe, because it's one of the enablers of AGI and ASI. What we know, since we observed the space somewhat, is like all of these server farms are ramping up like crazy. There's a lot of money getting poured into GPUs and so forth in order to ramp up computer resources. And the most important resource here is basically also energy. I know you are very deep into energy topics. And I think in our society, I mean, different jurisdictions approach this topic in a different fashion. Some are more on the side of, hey, we need to be less wasteful with energy and so forth. And then there are the other people, like proponents of the Kardashev scale, for instance, who say, hey, actually, we need to consume as much energy as possible. We need to be able to access as much energy as possible. And there are like obviously substantial correlations between GDP and energy consumption. So I'm wondering, this might be a bottleneck for AGI and ASI. How do you see this matching the timeline? Do we heavily need to ramp up fission and fusion? At what time will we enter the Dyson spheres, for instance? Like maybe give us some insights on how we solve the energy bottleneck, because that is basically the key enabler to all of this innovation and AGI and so forth.
Yeah, so to help your audience, sort of at the very bottom of the AI stack is energy and silicon, the AI chips, right? And then those get combined together into a form of data center. So the data center is running AI chips, which can consume energy. And then from that data center, that's where the AI algorithms themselves are run for the training and for the inference. Or maybe lightweight last mile training or lightweight inference is run locally on people's devices, et cetera. And then it all leads to the last mile apps at the very top of the stack, right? So that's it overall, what I see actually is that medium term, 5 years plus, et cetera, energy is likely the bottleneck. Right now, there are two bottlenecks, energy and chips, right? The reason that there's a bottleneck in chips is there's only 4 companies in the planet that can make cutting edge CMOS. And you need the cutting edge CMOS to be cost competitive at all, right? These 4 companies are TSMC in Taiwan, Samsung in South Korea, SMIC in China, and Intel in USA. And NVIDIA, which is a USA-based company, but manufactures their chips in TSMC in Taiwan, they have been so far the biggest winner of the AI demand boom, largely because they developed an ecosystem around their chips as well, via something called CUDA programming language. And that allowed AI researchers to write higher level code that then would be hardware optimal to squeeze the most efficiency. So the big nations of the world are understanding the need for this from the silicon perspective. And actually many nations haven't figured this out yet, but it's really, really critical, right? It's a bottleneck. We see example symptoms of this. There's stories of Elon Musk and Larry Ellison sitting down, having a meal together with Jensen Huang, the founder and CEO of NVIDIA, saying, please, please, please give us GPUs. And they're basically negotiating to get the most maximum GPUs that they can get. And there's a huge shortage. NVIDIA is sort of the guaranteed gold standard, if you will, but there's other ones coming along that people are resorting to as they need. So that's the silicon side. Silicon is definitely a bottleneck for the next several years, right? And it's stuff surrounding the silicon too, like energy management, et cetera. Let's talk about energy. There has been projections where, roughly speaking, the energy demand growth will be 2x to 5x per year from the AI, depending who you ask, depending what figures. But that's super aggressive. And what that means is if we were to follow those projections, I think Eric Schmidt, who had been co-CEO of Google and chairman of the board of Google for many, many years, one of the smartest people out there for sure, and has a big picture view of this all. I think his number was something like 99% of current energy consumption in the USA would be eaten by AI by the year 2030, which is only 5 years away, which is just insane growth rates if you think about it, right? Yep. Now, of course, you can't just eat up 99% of the energy and leave 1% for the people to power our computers and our homes and stuff, right? You have to have more energy. But there is going to be a squeeze, right? So one example of a squeeze, we just saw a deal from Meta a couple weeks ago where they spent, it looks like about $17 billion deal to have access to all of Chicago's nuclear power. So for the last several decades, Chicago has been powered by fission reactors. And it's not really a widely advertised thing, but it's been happening. But Chicago, for whatever reasons, the leadership of Chicago decided they wanted to go to renewable power. the nuclear reactors were hitting year 40 of their cycle, and that was the official phase out timeline for them. But Meta came to them and said, hey, do you really need to phase out at year 40? Can you last another 20 years? The people running the reactor said, yeah, we can last another 20 years. So Meta cut the deal with them for the next 20 years, $17 billion deal, I believe. And now Chicago itself, the city of Chicago has to scramble to try to get energy in other ways with wind and solar, et cetera.
Yep.
But that's an example of sort of a zero-sum game in the near term of energy for consumers versus AI. Energy prices will probably spike for residents of Chicago in the next year or two, but then they'll come down again as the solar gets built out, et cetera. And we're going to see energy prices spiking throughout the world as there's near-term demand for these AI data centers. The capacity isn't there yet in the West. There's many, many more examples of this. We're seeing the prices and stocks of nuclear-related companies going up like plus 50% in the last 3 months because of this too, et cetera.
Yeah.
So it's starting to happen, but we ain't seen nothing yet, right? Because it's so much bigger than people realize, right? We're talking, like I said, 99% of current energy consumption in the USA. By 2030, that's only 5 years away. China, by contrast, has an aggressive plan to build a nuclear. They've had it for a few years, and they're building a nuclear. But it's not just nuclear, right? It's whatever you can get your hands on everywhere, right? In China and USA, et cetera. So Trump has talked about drill, baby, drill to unlock Alaska, reopening coal throughout USA. And coal is a lot cleaner than it used to be. Not like it's clean, but it is cleaner. Solar is actually probably the fastest way for people to scale because, you don't have to wait for regulations in a big way or anything like that. And geothermal where you can, right? Canada, turns out it has a ton of geothermal that's barely been exploited. Interestingly, Kenya has the most geothermal. Iceland, famously, a lot. It's actually number 2, and so on and so forth. So I've looked into this a lot. And the reason I have is simply because for AI, like I'm thinking about, okay, what's going to be the bottlenecks for AI? And the way to think about it now is AI is the big final customer for all of this stuff. Just like for the last 15 years, smartphones were the big final customer for semiconductors, right? Or even 20 years. So now AI is becoming the big final customer for silicon and for energy, right? And interestingly, the energy regulators haven't been traditionally planning for this, right? They have their projections of 3%, 5% per year, but now it's radically more, right? So they're having to start thinking about how to retool this. This is also why a lot of these hyperscalers and stuff, they're not even connecting to the grid, right? They're just doing this 1-2 pair of a power plant next to a data center, and then you don't have to worry about transmission or hitting the grid. And it also economically makes sense because it's a lot cheaper to transmit bits than it is to transmit electrons, right? Transmitting electrons over long distances, this is a big problem. This is why there's lots of research in superconductors and so on, right? But it's expensive. It's very lossy over longer distances. So yeah, that's how I see it. Big scale up, tons of money being spent on this, and we're only at the beginning, right?
Yeah. Great view. I share most of your takes, to be honest. I also think it's very nice to see that Bitcoin mining is actually accelerating these activities in terms of how can we source different sources of energy, also in terms of renewables. And as we ramp up the renewable sector, it's also cool to have like Bitcoin mining facilities who are known to be grid stabilizers, right? So we appreciate that you provide such detailed answers. Unfortunately, we're running out of time. So what we do now is there's a lot of stuff we wanted to chat with you. We do a quick round of some rapid fire questions. You have to answer very concisely, high pace, but also short questions, okay?
Yes, but maybe before we get there, I think because I've been hinting at it before, I think it's unfair to your audience. Maybe I'll take 2 or 3 minutes to lay out the brain-computer stuff, because I think that's really sort of wraps things up with a bow, and then I'll go to the rapid fire.
Go ahead.
So I've hinted at this before. Basically, what happens when we have these artificial superintelligences that are 1,000 times smarter than us, right? And a lot of people are saying we need to align them, et cetera. But the thing is, think about ants, right? Like those insects at your feet, right? Imagine they came to you and said, we would like you to change how you think to align yourself with ant values. What would you say, right? You'd be like, go away,
it's not
screw
happening.
off, right? Not happening, exactly, right? So these ASIs, and by the way, the ants can't control us either, right? We have way more power than them because we're way smarter than them, right? So we have to think about it this way with the ASIs. From making money and power to be retained, there's this big arms race for AI to get to AGI, but then it's going to keep going because there's money to be made, power to be retained. Because of that, we're going to get to ASIs. The thing is, when we get to ASIs, these things are going to be wildly smarter than us in our current form, right? And we're not going to be able to align them with human values. If we're lucky, they will be aligned in some way, but we have no guarantee of that, right? It's a fact of life. It's going to happen, right?
Yeah.
So, and then the question is, what do we do about it? And some people and many good friends say, okay, well, I'm just going to hope and pray. Like, I'm going to hope that they treat me well, and I'm just going to go off on my farm, whatever. And maybe I'll keep my job, maybe not, but I've got some saved away, so I'm happy with that, right? For myself personally, I want to have a role in the future, right? I want to explore the cosmos, and I also find it annoying that my body will give out on me in less than 100 years, right? My current meat-bag body. So how might I get super intelligent? And there's kind of two paths. One is uploads, but the challenge with that is we're at least 15 years away for that tech, right? Which is not in line with the timeframes we're talking for ASI, right? ASI, we're talking a time frame of, say 1.5 years, 2.5 years. It's not far away, maybe 5 years max. So what might be a fighting chance? And the other approach besides uploads is using brain-computer interfaces as a bridge. So the general idea is we've got a left hemisphere, a right hemisphere. Let's have a third hemisphere, a digital hemisphere that we're talking to in high bandwidth, and high bandwidth using brain-computer interfaces. Non-invasive as much as we can, at least at first. So using EEG, but that's probably not enough. That's electrical signals. We can use FNIRS, which is infrared, to talk back and forth to this digital hemisphere, this third hemisphere. And that might get us enough bandwidth on its own. Our left and right hemisphere, they talk back and forth via the corpus callosum, which is only 50 kilobits per second. That's only at the level of an old school modem. So with FNIRS, the infrared approach, we might be able to get 50 kilobits per second from that. And that is maybe enough to get high bandwidth back and forth interface. Typing isn't enough, speaking isn't enough. This might get us there. If not that, then we can get farther, and maybe we go invasive like Neuralink style, like Elon is doing, and so on. But for sure, we can do things like infrared based. The first step in general is to start to find killer apps for these brain-computer interfaces that hit mainstream. And then to attach these to huge markets. In this case, just like, these augmented reality glasses, AR, XR glasses, are going to hit mainstream in 2 or 3 years. How, you can attach yourself to those where to have really fast interactions with the glasses, rather than just relying on typing or twitching your fingers or something, you can have the high bandwidth brain-computer interfaces, right? And attach yourself to that. And then you basically attach yourself to this $1 trillion market of smartphones, and then basically run with that as a way to fund yourself, grow faster, and hit the mainstream, right? So this to me is a path. And eventually, maybe at first, this digital hemisphere will be maybe 1/10 of your compute power, but it will still be you because it's such high bandwidth back and forth to you. It'll feel like it's part of you, et cetera. It goes from 10% to 20% to 50% to 100%, 1x, to 2x, to 5x, to 10x, to 100x, to 1,000x, right? And that will take several years, maybe 2 years, maybe 5 years, maybe 10 years. But at some point, when it's 1,000x compute power of your brain, of your meat-bag brain, but it's still you, it's this digital part is just way more of the compute power. It's still all you. Now, though, you are par with the superintelligences. And that's the key thing, right? So we have a path where we can leverage off-the-shelf technology plus the right research in just the right places, leverage market forces and brain-computer interfaces to basically take advantage of the advantages of silicon for our human selves to get ourselves to human-level superintelligence. To me, that's the most important thing I could possibly work on, in my view. And so I'm spending time at it. Within Ocean, we have a project working on that, and we're going for it. It's still in research phase. We're hopeful about it. No guarantees. There's some pretty promising research out there that we're looking at, and some of our initial results are pretty cool too. So that's how I see it. But ultimately, the name of the game is we know for sure that these superintelligences are going to be out there. They're going to be able to explore the stars and make Dyson spheres on their own. And I want to join them, right? I want to be part of that as a human superintelligence, or, maybe when my body hits 90 years old, I unbound myself and, let go of the meat part and go full digital, right? And maybe other people feel that way too. And so that's fine. And for people that don't, that's their choice too, right? To each his own. So that's how I see a future. And this ties in with blockchain, of course, too, because along the way, I mentioned before, we don't want our raw signals being intermediated by middlemen that end up in the servers of NSA or otherwise, or raw neural signals. So this is where trustless permission for data access is really important, right? Your keys, your thoughts, not your keys, not your thoughts. So a key part there. So yeah, that's a bit of a summary of how I see the future. And it combines crypto, but especially AI and brain-computer interfaces for a very exciting future for humanity, or whatever we might evolve into.
Nice, thanks. But now rapid fire, quick one.
Yes, I would like to ask you about possible path dependency here. Like, I see the chance that the ASI is achieved much earlier than brain-computer interfaces, because even with infinite or abundant energy and intelligence, there are still biological processes that are slow. You want to test side effects, long-term effects. There are still laws of physics. So, I don't think we are reaching super compressed timelines necessarily. But my question to you is, what happens in that case? What if ASI is achieved long before?
Yeah. So I agree. Right now, we're losing the race. There's really, too few people are working on accelerating BCI. I actually call it BCI ACK. That's the name of the game, because we need to accelerate to have a fighting chance. And it really depends on the timeline then of ASI taking off and dominating our lives. Maybe it'll take off, but it won't dominate us for a few years. Maybe it'll take off and dominate everything right away. Then we for sure don't have a chance. But there's many scenarios where it might be a bit slower, or where we find ways to really catalyze and accelerate the BCI side. So there's some scenarios where it could really work. And my view is we have to try, right? It's just a no-brainer. So maybe we have no chance at all in some scenarios, but yeah, there are some scenarios where it will make the biggest difference in the world. So we have to try.
What about society? We know there's a lot of concerns about jobs, especially it starts with white-collar jobs, then maybe everybody else. How will in terms of purpose, what do humans do afterwards? It can be very dystopian, but it might also be utopian. And then what about the population? It maybe also unlocks longevity stuff, and we have declining fertility rates already. So how does that look like in the future?
Yeah, so I see that jobs and societal people is the second most important problem, right? The first most important is how does humanity play a role in the future? And that's where the BCI acceleration comes in. If we don't crack that, then nothing matters, 25, 50 years from now, right? Could be just, we're left behind. But it's a crazy important thing. I see that AI will take all the jobs. Lots of people like to say AI, Mark Andreessen said, AI will take every job except for that of VC. I used to say AI will take every job except for that of AI researcher, myself being an AI researcher, right? So we're all very egocentric about this. But then I realized, what am I talking about, Trent? I know lots of AI algorithms that already take over for a lot of the AI work that I do. So AI will take over all the jobs, bit by bit by bit. You might say, oh, well, what about empathy? Well, in Japan, people in nursing homes, elderly citizens in nursing homes prefer robot nurses compared to human nurses. And they actually think that they have higher empathy. Which I'm not sure, it depends how you measure it, but overall, that's amazing, right? And remember, humanoids are going to be coming on strong. We hardly see much of them now, but that's going to be a huge thing, right? This is humanoid robots where AGI level intelligences are living inside humanoids, inhabiting these spaces. That's going to have a huge impact. So all these jobs that involve manual effort by humans, now we have a robot that is shaped of the human form that can fit into all these spaces that were designed for humans, right? And declining birth rate, it is what it is. Maybe governments will slow it down a bit, but I don't see it making a big dent. But humanoids will fill the gap in many ways too. Then in terms of what do we do? I think it's really important that we separate having a way to feed ourselves from having a way to self-actualize, right? And probably most humans in the world have jobs that are not self-fulfilling. I'm sure there's lots of stats on that, right? If you're working at McDonald's, I'm sure that wasn't your dream job, right? If we have a way to feed ourselves without having to work, but instead some other way, maybe UBI, maybe otherwise, great. If we don't, that to me is a big open question, and I'll get into that. In terms of finding something to do, I think it's up to any given human, right? What is it that you want to do? Do you want to go write the great American novel? Do you want to own paintings? Do you want to play video games in your mother's basement? Up to you. The bigger challenge actually is if too many jobs get lost and there isn't enough way for people to feed themselves, what do we do then? UBI is maybe an answer, but it might be too little too late. And we're starting to see hints of that now where jobs are being lost from, AI or otherwise. And there's more and more societal people, more and more rich get richer, poor get poorer, and so on, with many factors causing it. Although I think every generation will talk about that too, right? How, oh my God, it's worse than it ever was. But at the same time, it's better than it always was too, So it's both ways. So overall, I can be sad about it or I can be excited about it. And I choose to be excited about it. I choose to build. I choose to be excited about the future. I choose to move the needle where I can. And I see that, like I mentioned just earlier, my team can and many others can too, have a big impact in the future by identifying where the needle can be moved to make a big impact. For me, it's accelerating BCI. But there's so many things, even in the next couple of years, on AI and blockchain too, that we can make a difference too. So there's lots of ways to make a difference, to each his own on that. And we all have to be ready for a grand adventure. The next 5 years is going to be wilder than the last 1,000.
It's insane, yeah. Thanks.
Trent, I need to ask you this because it really triggered me. So you said over time with BCI-ACK and the high bandwidth brain-computer interfaces, we can enhance our brain and become 2x more intelligent, 10x more intelligent, so on. But you also said it's still you. So you are okay with this gradual improvement. But you also said previously that 1000x intelligence is qualitatively different, something completely else. So what makes you in this process? What is the core of humanity, of your persona, of you? Yeah.
So Wolfgang, you were 2 years old at one point, and then you grew, right? You grew from a 2-year-old to a 10-year-old to your current age, but you were still you the whole way, right? I view the same thing with ourselves, but now we go from, my 2-year-old self to my current year-old self in terms of level of intelligence. It's another 1000x beyond, right? You can start with the ship of Theseus idea where you replace every plank in a ship one at a time and still the same ship. But instead of just that, it's also including growing. So my mind is currently a shack, but then I'm going to grow it into a house, and then a mansion, and then an apartment building, then a small skyscraper, then a large skyscraper. So it's going to be wildly more powerful, but it's still me, just like I grew from my 2-year-old self to my current self. And I will have grown and evolved and all that, but there have been that continuous thread, right? And that to me is the exciting thing, because then, and I might be radically different then, just like I'm radically different now compared to my 2-year-old self. That's okay. And some people will choose not to, and that's their choice, right? Mm-hmm. And I can't imagine anything more exciting than growing much more. I'm watching my children grow up, and I see it's so wonderful to see them grow from, a 2-year-old way of thinking to a 10-year-old way of thinking and so on. And I'm excited to watch myself grow from my current age, my current human, biologically constrained, bound way of thinking to something 1000x more.
Absolutely.
Awesome.
Thanks.
Last question, because a lot of people a little bit more deep in the investment space are also tuning into Verified. How can you, from an investment perspective, how is money changing with the emergence of AGI and ASI? How can you prepare for this emergence of these super powerful models and AI? What does it do to the investment landscape in your view?
It's a good question. I think once ASI emerges, all the rules change. It's really tough to predict, honestly. And even maybe with AGI, right? My good friend Ed Hesse has talked about how, look at the graphs, all the graphs stop their predictions in the year 2027, right? Mm-hmm. And it makes sense, right? I can totally see why. So, but there is a near-term thing as from an investment landscape. And I hinted at it before, talking about, we are now in an era very similar to the beginning of the second industrial revolution, where if you invest heavily in infrastructure for oil, infrastructure, and energy and so on, Rockefeller style, you win then. Now it's basically up and down the AI stack, but the bottom half of the stack, where it's 90% of the CapEx, you can invest heavily into CapEx and get outsized gains, right? We're seeing the hyperscalers do this aggressively. You can invest directly in the stocks, in the crypto tokens related, all of this, and that's the most obvious play, as well as in early stage companies. There's a handful of fusion companies. That's going to get really important in the next 2-3 years as they find ways to go into production and so on. Fusion is really close, right? We don't need to wait for AI to invent it. There's already many companies in play. So that's the near-term benefit for your investors, is basically go for the CapEx spends on the AI stack. There's big gains to be had there.
That makes sense. Basically, also in terms of what resources will they need, silicon and energy. All right, that was a super nice discussion, almost mind-blowing in some regards. I think both Wolfgang and me are having deep discussions on the risks of AGI and ASI. And usually we also end up on a positive note, because to some form, maybe these models are just an average reflection of humankind. And I would say overall, humans lean more into something good than something bad, I would say. And maybe this holds true for the models.
I would disagree with that, actually.
Sorry?
Intelligence is, I heavily disagree with that. Intelligence is unbounded.
Okay.
Our intelligence as humans is only bounded by the size of our skulls, which is bounded by, what can pop out of a woman when she's giving birth, basically. That's it, right? But imagine if you can have a brain that's 1,000 times or 1,000,000 times larger, right? Intelligence itself is unbounded. We just can't conceive of it, just like ants can't conceive of our intelligence. It's really important to understand that, right? We like to have these pretty ideas, this very anthropocentric idea that we humans are the epitome and all that, and AIs are just a reflection of it. This is not what's happening. It's something radically bigger and so on. And, after 2027, when the predictions end or whatever, these ASIs are going to keep going, 10x a year, or maybe eventually 10x every 5 years, who knows, towards Dyson spheres, all this. And the only question is, can we as humans join them or not? That's it. But that's a very exciting question. Let's join them.
Yeah, fair. I guess, maybe my point was more that I do think that these models will more lean into the good side than the bad side. So we also believe we are rather
in terms of alignment, you mean?
Yes.
Alignment.
We have no guarantee of that, right?
So no, of course not. But it's basically do you choose the good, or do you choose to be hopeful, or do you just choose to be highly concerned about what is happening?
Well, the ants might be hoping that we humans get aligned with them. But we don't really kill them too much, right? And now and then, if they crawl around us too much, we might stomp on a few, but we let them be, right? They have a bigger biomass than humans on Earth, right? So we let them be. So I think that's a happy path. But we shouldn't assume that the values of superintelligences are fully aligned with humans. In fact, that's a low probability. But I think there's a bigger probability that they don't care enough about us, right?
All right.
Yep.
So thanks for sharing the time with us, Trent. It was really an awesome discussion, as I outlined. We will provide some more info in the show notes if you want to follow Trent, dive deeper in what he's doing. And with that, thanks for your time again, and see you next time.
For sure. Thank you very much. It's been great.